I'm Miss Reeb Exotic, and this ain't going out to no unmotivated students. First thing is, I am not cutting my hair. I'm not changing the way I dress. I refuse to wear a suit. I am a teacher. I taught 2 subjects in my life. I currently teach math. Thank God it's finally legal online in America. I've had some fun with online learning. I have tried Edmodo through the younger years of the quarantine. I am tired as heck. I have a judgment against me from some kids down there in Florida, but I can tell ya, I'm trying real hard to make things interesting, and that does not mean I'm watering down our math class. I built one of the best online classes and the most fun online classes in the country. I am Miss Reeb Exotic, and don't forget, I'm here to teach you math. So let's go over the study guide. Number 1 asks you to tell if the number is rational or irrational, and then why. So our first number is 6.988888888, whatever. The 8 goes on forever and ever. This is a rational. This one is rational because it's a repeating decimal. Repeating decimal. Now this guy, 2.010010001, although it is a pattern, it's not repeating because it's something different every time. This only had 1 0, this has 2 zeros, this has 3 zeros. So this will go on forever, but it doesn't actually repeat. So this is irrational. It's irrational because it goes on forever and it doesn't repeat and it doesn't end. So it goes on forever, but it doesn't repeat. The square root of 64, if you were to plug the square root of 64 into your calculator, or if you just happen to know that that's a perfect square, it's 8. 8 is an integer. Integers are rational numbers. Rational. Why? Because it's an integer. -51/5. This is a fraction. When we did this video on March 23rd, that's the date that we did this, by the way, March 23rd. In this video on March 23rd, the guy in the video talked about how if it is a ratio, it is rational. And a fraction is a ratio. So this fraction is rational. Simply because it's a fraction. That actually is the definition of a rational number. Rational numbers can be written as fractions. The square root of 6 is somewhere in between the square root of 4 and the square root of 9, which means that it's somewhere in between 2 and 3, but this decimal will go on forever and ever and ever, so this guy is irrational. Irrational because this decimal, if you were to turn this into a decimal, would go on forever. Decimal goes on forever. So take a minute to pause this video and check your work. Alright, question 2. We actually did this a bunch of times. I do remember making a lot of videos about this. Number 2 is write this repeating decimal as a fraction. So we did this on March 24th. We did it on March 24th. And the first thing you're going to do is set this repeating decimal equal to x. So x equals 0.6 repeating. The 6 is going to repeat over and over and over again. And now what we're going to do is multiply either side by 10 to the first power. 10 to the first power times 10 to the first power. And it's the first power because there's 1 decimal under this bar. So this side ends up being 10x equals, when I multiply 10 to the first power, I move it 1 space, so 6.6 repeating. And now what I'm going to do is subtract an x from this side and subtract a 0.6 repeating from this side. Because x and 0.6 repeating are the same thing. We already said that up top. So we end up with 9x equals 6. If we want x by itself, we divide by 9. And we get x equals 6/9. This can be reduced. Both of these numbers go into 3, so I'll divide the top by 3. I'll divide the bottom by 3. And that gives me 2/3. 2/3 is the fraction form of 0.6 repeating. And if you're looking for the word, you can go back and write down all the words that I say as I'm doing that. So number 3 said to write all of the numbers that aren't decimals as decimals and create a number line and then put all of these on the number line. So the first thing I'm going to do is write them all as decimals. I know that pi is 3.14159, blah, 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 goes on forever and ever. I'm just going to narrow it down to 3.14. The square root of 17, we'll have to do some rational approximation. I know that the square root of 17 is somewhere in between the square root of 16 and the square root of 25, which means that it's somewhere in between 4 and 5, and I know that 17 is super close to 16, so I'm going to try the decimal 4.1. And I get 16.81, which is pretty close to 17. So the square root of 17 is approximately, this little squiggle means approximately, 4.1. Because 4.1 times 4.1 gives me a number that's close to 17. And we'll do the same thing for the square root of 7.
The square root of 7 is in between the perfect square root of 4 and square root of 9. The square root of 4 is 2, the square root of 9 is 3. So I know 7 is going to fall somewhere between 2 and 3. I'm going to try 2.6. So 2.6 times 2.6. And I know that 6.76, which is pretty close to 7. So the square root of 7 is approximately 2.6.
And now we have all of our decimals, we've done our first step. Now what we're going to do is put these numbers on a number line. So the first thing I need to do is make the number line. I'll just draw a line right across my board. It looks like my lowest number is 2.6, and my highest number is 4.6. So I'm going to make this line go in between 2 and 5. Starts at 2, ends at 5. That means that I need a 3 on here, I need a 4 on here, and I'll even label my 2.5, my 3.5, and my 4.5. And now all I need to do is put these numbers on this line. So 4.6 is right about here. 2.8 repeating is right about here. Pi is 3.14, and that's right about here. The square root of 17 is about 4.1, which is right around here. And the square root of 7 is about 2.6, which is right about here. So we just put these on the number line. If the question told you to write them in order, you would just write them down in this order. Square root of 7, 2.8 repeating, pi, square root of 17, 4.6. And this is the order from least to greatest. Let's move on to number 4. I forgot to tell you, we did number 3 on March 27th and on March 30th. Question 4 is about town hall. The first thing it tells you to do is draw a picture. So that is exactly what we're going to start with. It says that town hall is 4.3 miles east of the middle school. So what I'm going to do is put a dot on my paper and label it MS for middle school. And town hall is 4.3 miles east. So east is this way, right? Never eat soggy waffles. East is that way. So I'm going to draw a dot east and label it TH for town hall. And this distance is 4.3 miles. The next part says the fire station is 1.7 miles north of town hall. So I'm going to go north of town hall, label it FS for fire station, and this is 1.7 miles. It's okay that it's not perfectly to scale. And the question is asking us, what is the distance of a straight line between the middle school and the fire station? Well, I'm looking at this and I see that I have a right triangle. So this is going to be a Pythagorean theorem. A squared plus b squared equals c squared. Our a value is 1.7, so 1.7 squared, plus our b value is 4.3, so 4.3 squared equals c squared. That's what we're looking for. 1.7 times 1.7 is 2.89 plus 4.3 times 4.3 is 18.49 equals c squared. 2.89 plus 18.49 is 21.38 is c squared. And now if we want to find c, we're going to take the square root because the inverse of a square is a square root. So the square root of 21.38 is 4.6 miles. So that means that this line right here is 4.6 miles. And now we're moving on to part B. Part B says that the hospital is 3.1 miles west of the fire station. So that means that if we were to go 3.1 miles away from the fire station, let's say right about here, this is 3.1 miles, this is where the hospital is. And this question is asking us for the distance between the middle school and the hospital. And we can actually use the Pythagorean theorem for this as well. See, if I were to draw a line right here, this distance is still 1.7 miles. These two lines are parallel to each other. So this is still 1.7 miles. And in order to find out this bottom portion, well, I know that we went this way, 3.1 miles, so we need to figure out what's left. So we have 4.3 minus 3.1. 1.2. So this little piece is 1.2 miles. And now that we know that information, we can use our Pythagorean theorem. A squared plus b squared is c squared. Our a squared is 1.2. Squared plus our b squared is 1.7. Squared equals c squared. 1.2 times 1.2 is 1.44 plus 1.7 times 1.7 is 2.89 equals c squared. And now we'll add them together and we end up with 4.33 equals c squared. And if we want to get the c by itself, we take square root. And we end up with about 2.1 miles is c squared. So it's 2.1 miles to get from middle school to the hospital. And there you go. Serafina says that triangle KML is a right triangle. Is she correct? Basically what we're doing here is a proof of the Pythagorean theorem. We did that on April 6th. Basically what we're going to do is plug these three things in to a squared plus b squared equals c squared and see if it's equivalent. So a squared plus b squared equals c squared. Our a value, I'm going to say, is our smallest value. It's this 12. So 12 squared plus our b value, I'm going to say it's the value on the bottom. So it's 16 squared equals our c value is always the longest value. And it is also the side that is opposite of what we think it might be the right angle. So that makes our c value 19 squared. 12 squared is 144, plus 16 squared is 256, equals 19 squared, which is 361. But 144 plus 256 is 400, which is not the same thing as 361. I put an equal sign with a slash through it because they are not equal. So this triangle right here is not a right angle because 400 does not equal 361. All right, number 6, we have this box, and we have this girl, Kylie, and she wants to bring her 38-inch baton. We learned about this 3D situation on March 7th. All right, and would her baton lie flat along the diagonal of the box? Well, let's find the diagonal of the box. This diagonal right here would be this triangle. Oops. This direction is 13. This direction is 35. And they're looking for the length of the diagonal. So this is a squared plus b squared equals c squared. A is 13 squared plus b is 35 squared equals c squared. 13 times 13 is 169 plus 35 times 35 is 1,225 is c squared. 169 plus 1,225 gives me 1,394 is c squared. In order to find c, I take the square root of both sides, and I end up with 37.3. So her baton would not fit because 37.3 is smaller than 38. But part B wants to know, will it fit diagonally across the whole box? If we were to start at the top corner and make our way to this bottom corner, I can already tell that's a longer line, so maybe it'll fit that way. Well, we know that this little section is the square root of 1,394. Square root of 1,394. And we know that this part of the square is 13 because it is parallel to this part of the cube, which is also 13. So this triangle looks like this. This direction is 13. This direction is the square root of 1,394. And we are looking for this diagonal. The reason that I'm using the square root of 1,394 is because when we square this, we're not going to get a decimal because the opposite of a square root is squaring something, and I'll show you what I mean in a minute. A squared plus b squared equals c squared. Our a value is 13, so 13 squared plus our b value is the square root of 1,394 equals c squared. 13 times 13 is 169. 1,394 the square root of 1,394 squared is 1,394 equals c squared. 169 plus 1,394 is 1,563 is c squared. I'll take the square root of both sides to get c by itself, and I end up with 39.5 equals c squared. So will her baton fit? Yes. Because 39.5 is greater than 38, which is how big her baton is.
Carol Baskin killed her husband, whacked him. Can't convince me that it didn't happen. Fed them to tigers, they snacking. What's happening? Carol Baskin.